Hi, welcome to this implementation demo of a Postfix++ evaluator. I'll walk you through this JavaScript application, hopefully making it easier to understand and grade my code. So let's dive in. So the first step is setting up a symbol table class. And you can think of this as our calculator's memory where the variable names and their values are stored. And the pseudocode in the report would outline this as initializing a symbol table with arrays to hold keys and values, as you can see here. This setup ensures that every variable we define has a corresponding place in our symbol table, allowing for efficient storage and retrieval. Next, how do we insert new variables and search for existing ones as well? Well, the pseudocode in the report highlights that if a variable exists, update its value, otherwise add a new entry. And as you can see here, the code closely follows this logic. The insert method ensures that each variable is stored or updated, while the search method retrieves the value of a variable, throwing an error if it doesn't exist. And this is a very comprehensive function. And aside from variable storage, it does handle additional methods that compute mathematical functions such as sine, cosine, modulus, and so on. And we're going to look at that later. The following step is the heart of this application, which is assessing the RPN expressions. Consider the pseudocode to be a chef explaining a recipe, with each step necessary for a meal. This recipe begins with a loop that goes through each token in the expression, adding integers to a stack and performing operations. And this method is implemented by attaching the evaluate RPN function to the symbol table. And so what's happening is the function checks tokens to see if they include numbers, variables, or operators. And so adding a number to our stack's mixing bowl is like adding an ingredient. And when a variable is used, this function looks up its value in the symbol table. And so this is like the chef locating the right spice, say, in a well-organized pantry. So for example, if the token is A, the function checks the symbol table and adds it to the stack. And actually, let's see this in action. Let's say, as an example, we want to evaluate the expression A4+, where A is a symbol table variable with the value 3. The first thing is we need to assign the value. And how do we do that? We've got a help menu here, and we can see how to assign a value. So we're going to assign A to the value 3. Now we can see that A is a new variable in the store. What's happened now, the expression A4+. What's happening here is that the evaluate RPN function will retrieve 3 that is assigned to A. It then moves 4 up the stack and finally adds them together to produce 7. And this smooth interplay between the evaluate RPN and the symbol table is what is allowing these expressions to use the variables very efficiently. And we can look at other examples. For instance, we can even look at the modulus, and we can see that this is working quite well. We can look at some trigonometric functions, right? And we can even try and evaluate longer expressions just to see how this would evaluate. Voila. And we can, let's also add some variables to our store. And we also have a little error handling. So we can see that C is not a variable that's defined. So in a nutshell, the tokens are processed in a loop where numbers are loaded onto the stack, and the operations pop the values from the stack where they conduct the operations and they push the result back. And this is referencing the stack operations lectures in this module. So that concludes my walkthrough. We've seen how pseudocode translates into actual code, handling everything from variable management to complex expression evaluating. Happy calculating, and thanks for watching.